Hello everyone. I'm really glad to be here today. Welcome to the sauna. I think we're lucky because it's not that hot yet, and the UBS coffee stand has already opened, so we're caffeinated. Yeah, we'll be talking about defense and tech techniques for modern web applications. Uh, this is Michele. I'm Lukas. We're both working in a special focus area at Google in Zurich. The last you know, 2 or 3 years, we basically focused on stuff like content security policy. We did a year of research. It was in really bad shape, and we tried to get it working at Google, which was a very interesting task, and we wanted to share some of our things and lessons we learned. But we also want to talk about shiny new stuff. Some of that is not even fully spec'd yet, but it's kind of very promising in our eyes to, mitigate some of the current and upcoming threats in web applications these days. So we will start with content security policy. I just want to get a super quick feeling for who of you kind of have heard about it before. Maybe just raise your hands so I know that, awesome, there's some people here that have heard about it, exactly. So for the others, I'll do like a super quick run through, like not more than 2 or 3 minutes. So you basically get an idea what the first part is about. So content security policy is in theory as simple as a response header for HTTP responses. It's interpreted by the browser, and it can be used by developers to lock down the application in certain ways. Most importantly, to highlight here, this is a defense in depth mechanism, right? So it's not a replacement for secure coding practices, nor for doing a careful input validation or output encoding of user or attacker provided content, right? So it's a safety net. If you have a critical application like a banking app or Gmail, right? There's a lot of secure coding practices, but every now and then, because the code base is so big, there will be a bug, right? There will be a cross-site scripting issue, and it's very good to have something that protects the user in the case that you have missed something in your product. What is CSP not? It's not a mechanism to prevent data exfiltration. I have a slide later on that, but we're just seeing it used as that quite often in practice. So we just wanted to bust some myths here. CSP is terribly complex. It's around for, I don't know, many years now, and over time they have, they were adding new stuff to the spec, and it's basically doing a lot of things. Unfortunately, not very well for most of the cases. But if you know the pitfalls, you can use it in a very powerful way, and this is something we will talk about today. I'll just highlight the most important use cases. There might be others as well. First of all, cross-site scripting. This is a web threat that we are still facing nowadays. There's good frameworks that help you to prevent it to happen in the first place, but there's a lot of legacy apps, and there's other cases where you will still have XSS. And at Google, it's still the #1 big issue that is reported by external security researchers. So especially for us, it's a big concern, and we actually want to use CSP to address that. Then you basically can also use CSP to restrict UI stuff. That's a bit advanced, but in theory, you can, for example, also build a tool that exfiltrates passwords just with CSS selectors. I have a slide on that later. So you can also restrict UI elements. And then there's completely different use cases to the loading resources main use case CSP was designed for. They kept adding new keywords to CSP because it was like a very convenient delivery mechanism. So for example, you can also use it to upgrade insecure requests or to just block everything that is not HTTPS. That's also kind of convenient to guarantee like a lower bound of security, but it's not in the focus of our talk today. And you can also restrict framing, like in the sense of like which frames you can load or which frame ancestors you can be loaded in. This is like mostly for click checking. You can do it for, content served, like if you serve user content, you could set like a default source none to prevent any active content to be rendered. And as I mentioned before, some people also use it to try to prevent data exfiltration by just, disallowing some fetch actions, but there's workarounds for that, and we'll show a couple of examples later. The main use case is, as I mentioned, mitigation against cross-site scripting. We did a CCS study two and a half years ago, 3 years ago, and we basically used the Google web crawler to find all the CSPs in the internet that were publicly accessible, and all of them were like kind of whitelist based. I'll talk about that in a second. And these policies can be, with some rules, very easily be like bypassed, like even in an automatic way. So we came up with a couple of rules and built a tool that was able to bypass like more than 94% of the policies automatically. And for us, this was the time where we said, okay, whitelist-based policies are probably not going to scale. We have to do something different. And this is when we basically switched to nonce policies, and we also added a strict dynamic to the spec to actually make it work in practice. I'll have a word on that in a second as well. So we're talking about a couple of flavors of CSPs that can protect against XSS or can't. There's like the whitelist-based ones. You basically have a script source that controls which scripts can be loaded. And the whitelist one is, for example, just ajax or google.com. So the browser will only be allowed to load scripts from that address, right? These can be trivially bypassed. Then there's like nonce-based CSPs. Is similar, but you have a random nonce. I'll show you in a second how that works. And only script tags that have this nonce attribute matching the one in the CSP will be executed. And then you can also use hashes. So you can hash an inline script, put the hash in the policy, and only if the hashes match, the corresponding script will be executed. So super quick intro. How does a trivial whitelist CSP work? On the right side, you have a content security policy response header sent to the browser. And on the left side, you have what the HTML markup is trying to do. So in this example, you have, for example, a script here, yep.com. And since yep.com is on the script source whitelist, it will be allowed to load by the browser. If you have a markup injection bug somewhere, like XSS, right? And the attacker injects a new script tag from attacker.com, the browser will say, attacker.com is not on my whitelist, I'll block it, so it will not execute. Same for inline scripts, they will be blocked as well, because they're like generally blocked in a whitelist scenario unless you have unsafe inline, which completely defines, like basically makes your policy completely useless in the first place. But yeah, so don't do this because this is like severely broken. There's a paper. There's a lot of bypasses. We have covered that in the past 2 years. Just a summary, but I mean, just hosting Angular and loading Angular on your domain can be enough to bypass the CSP if you use whitelists. It's very bad. Nonce-based CSP is much better in that regard. You basically just define a random nonce, and all script tags on the page must have this nonce as an attribute, and only if they match, the tag will be executed by the browser. There's a big advantage. You don't have to come up with a whitelist, so your application will not randomly break if you change paths, which happens quite often in practice, unfortunately. And there's no JSONP-like bypasses, and it's usually much easier and better to do it this way. So these will execute because they have the random nonce, same as in the policy. This nonce has to be random for every single response, right? Otherwise, the attacker can guess it or knows it, right? An attacker can inject script tags, but he does not or don't know the nonce attribute. So again, the browser will not execute it. What's the problem with that? The problem is if you load a Twitter widget or a, I don't know, +1 button or whatever other JavaScript library that dynamically creates script tags, right? It will fail because the Twitter library, if it does create element script, does not know the nonce on the page, or it could find out, but they don't set it on the child script. So it will break a lot of things if you use a nonce-only policy. In fact, nonce-only policies have been around for years, but no one is using them, mostly because of this reason. So what we did, we worked together with Chrome folks and the W3C people, and we added a keyword that is called strict dynamic. I know the name is a bit weird, but yeah, it is as it is. But the idea is, if a script tag on the page has a nonce, it's already trusted by the developer, right? So if that script tag creates new script tags, that will be transitively blessed by the browser. So you can basically propagate trust to child scripts. This is very convenient because suddenly you can use a nonce policy with strict dynamic with almost no refactoring on the page. And in fact, this is what we did at Google very successfully. And the thing is, there's a lot of backward compatibility quirks as well you can do, so it works actually quite well. And in addition to that, it also discards the whitelist, so developers cannot weaken up the policy in the sense that you are basically bypassable again, which is a nice property. The thing is, it only allows scripts that are created through the DOM API, like via create element script. It does not allow scripts, dynamically created scripts, to be blessed if they are created through like a parser inserted sync, like document write or in HTML will not be, if you create a script for that, it will not be blessed by strict dynamic. So this is like to make the adoption easier, right? But it comes at a cost. If the attacker or there's like user provided input here instead of a constant here, right? You could bypass the policy. But this is like a special vulnerability compared to all the other cases that are basically blocked by default, right? Like it's all the reflected XSS, all the stored XSS is basically blocked. So there's a couple of trade-offs and guarantees you can get depending what you do with a nonce-based CSP. There is like deployment difficulty going up and security guarantees going up the further you move up the pyramid. On the bottom, you have a nonce-based CSP with strict dynamic and unsafe eval. This gives you already quite a lot of guarantees for very easy rollout properties as well. So there's no CSP whitelist bypasses, there's no like classical reflected stored XSS because the nonce is not known to the attacker. JavaScript URIs will always be blocked, and it's kind of easy to deploy if you maybe have a templating system which also automatically nonces script tags. You should use a context-sensitive templating system though, otherwise you should, you might nonce a script tag that has user input in it, so that's also not cool. The other thing is, where it's not so good, there's some DOM XSSs are covered, like inner HTML syncs, right? But others, like DOM XSS will control the source of a script, are not covered by this policy. And also if you have unsafe eval and you have some user using eval and this user input, is also not covered. So you can move up. You can also prevent eval from being used. Some people can do it. Some libraries need it, unfortunately. We're kind of working on like killing it at Google, but it's still around, unfortunately. And even better is if you use nonces only, but you can only do that if you control the full JavaScript stack, right? If you load libraries from somewhere else and they don't do nonce passing, like if they do create element script and they don't do set nonce, get nonce from parent, like if they don't manually pass the script on, this will break. So this requires a lot of refactoring of your code base. We're currently working on that at Google. And the nice thing is it gives you even more security guarantees for DOM XSS as well, right? But I have to say, this one is already quite strong. For most use cases, there are some exceptions if you use some JavaScript frameworks which do like symbolic execution on top of JavaScript. Yes, and our right corner is whitelist-based CSP, like just don't use it. There's only very, very, very few instances where you can use that in the same way. Here's examples how a policy would look like in these scenarios. These policies don't have fallbacks. You can add browser fallbacks to basically make the policy gracefully, allow everything if you come with like a outdated browser like IE or something, right? You don't want users to break, or maybe you won't, I don't know. Yeah, so that's that, and CSP3 is actively developed. There's a couple of interesting new keywords being added, which we wanted to briefly mention. There's unhashed attributes, unsafe unhashed attributes, which basically allows you to have inline event handlers in the markup if you hash them, because with a normal CSP, inline event handlers are kind of blocked, so you need to refactor a lot of code. So if you have, I don't know, again, like some third-party widget or some code base which you cannot really touch, and there's like, 2 event handlers which you can't refactor, you could hash them and use unsafe hashed attributes to allow it. It is, of course, a trade-off, right? You will lower security slightly because attackers can inject this event handler in other items, right? So they maybe could chain some actions. But on the other hand, you will still get a lot of protection for like DOM access and the other things, right? So it still raises the bar, and it's probably better than not having a CSP at all. But yeah, I mean, I would only use it if there's like no other way around it, right? And then there's another feature which is unsafe inline attributes. This is a proposal and not implemented yet. There's a big difference between style blocks and inline styles. So you can also use CSP to restrict style source. This was like the UI attack vector I showed you at the beginning. Usually developers love inline styles. So if you don't allow unsafe inline for style source, your application will probably break, or you spend like the rest of your time to refactor developer code to move out styles into style blocks, right? So the idea is you can use unsafe inline attributes, which means you will not have to refactor inline styles, so this will work, but all the inline script blocks will need to be nonced or hashed. Will need to be hashed. So, or no, yeah, also or nonced. So the thing is, why does it make sense? Style blocks have more power than inline styles. For example, there's a proof of concept on GitHub that is like basically a CSS keylogger. And this keylogger needs CSS3 query selectors. And these query selectors only work in style blocks. So by forcing developers to hash or nonce style blocks, an attacker cannot inject any other style blocks if you have a markup injection vulnerability, right? And yeah, it's a trade-off because you could still inject arbitrary UI elements with arbitrary inline styles, but you cannot exfiltrate user passwords, right? It's a very interesting proof of concept. It's linked at the bottom. You should totally check it out. And I promised a slide on why not use CSP for data exfiltration. The TLDR is, as soon as you can execute scripts, it's game over anyway, right? So the main goal is prevent script execution in the first place. Otherwise, you have lost as a defender in this case. So if you have script execution, it doesn't really help you if the CSP blocks images and fonts and everything to prevent you from basically exfiltrating the cookie that you have stolen, because there's like so many other ways that are not governed by CSP to actually exfiltrate data. So for example, you could just write a link tag, evil.com, append the cookie, and then click it, right? So that would exfiltrate the cookie back to evil.com. And since navigation is not part of CSP, it cannot block it. So there's a lot of other possibilities like post message, DNS prefetch, window.open. You can use all of these to exfiltrate data. So the main goal really should be prevent the attacker from gaining script access in the first place. Don't try to prevent data exfiltration, because ideally it slows the attacker down a bit, but it's not a strong mitigation. It gives you a false sense of security, right? Very briefly, CSP at Google, with this non-spaced CSPs, we were basically able to roll out CSP so far to over 50% of all the outgoing traffic, all the important applications like accounts at google.com, Gmail, Drive, they have it. It was a lot of work, but this would not have been possible with the whitelist-only approach, right? Also, the whitelist-only approach was not very secure. Like it was not yielding many security guarantees. And yeah, we keep working on it. The goal would be 100%, but that's a bit unrealistic. We basically focus on the high-value targets, right, where the very important data lives in. And yeah, we also currently trying to remove unsafe eval. There's still a couple of libraries which we have to refactor to not use eval in the first place, so we can block it for the entire domain. And we're also working on teaching libraries to do manual nonce passing, since we are in the lucky position to control the entire JavaScript ecosystem. So we can use nonce-only policies. But again, the strict dynamic ones are, for the use case we have here, quite strong. We don't have any crazy libraries that inject like any gadgets that could bypass strict dynamic usually. So for our use case, it's quite good. And of course, during this journey, we also developed a lot of tools, which I recommend using. There's a CSP-evaluator with google.com. It basically, you paste a CSP, and it usually will tell you in how many ways it is broken. So if there's anything red, you have problem. So if you're developing a web app and you want to roll out CSP, maybe run it through here. You'll get some ideas how to improve it maybe. And internally, we also have a lot of tools that parse the CSP violation reports coming back from the browsers, because this is like a really huge task, because there's so much noise by browser extensions and antiviruses injecting, you know, weird scripts on every page, causing violations everywhere. So this is basically a tool we use internally to crunch down the violations, do deduplication, noise reduction. It's a bit fuzzy, but yeah. And with that, I will hand over to my colleague, Michele, who will talk about all the other new and interesting mitigation techniques.
Hi everyone. Thanks for coming, Sonomers. I don't know you guys, but it's really hot, so thanks again. Okay, so CSP at Google is, I would say, like the king of web mitigations. It's the most important one, the most valuable we have, mostly because we are focused in mitigating cross-site scripting, XSS. But there are other very promising web mitigation techniques that are little known. And with this second part of the talk, we hope to solve that, to actually create awareness of the existence of these tools that you as a webmaster, as a web developer can use to further secure your website. Or in some cases, there will be browser settings. So some browser settings, especially Chromium, that you can enable to have some extra layer of security. If you have any questions about CSP or any of the web mitigations, please save them for later. We'll be very happy to answer any doubts. Some of those are already in production. Some are being developed. So I will, for everyone, I will say what is the browser support, like which browser support which. So the first one is sub-resource integrity, or SRI. This is kind of the old web mitigation technique, or a hardening, if you will. SRI is more of a hardening. So it ensures that resources hosted on a third-party server have not been tampered with. So for example, if you include a script tag with a third-party JavaScript and the third-party server gets compromised, this means that it is basically XSS on your domain. Like the hackers can host whatever JavaScript they want on your website. So for example, some very high-value target would be CDNs that, for example, host jQuery or very common JavaScript libraries. You just include them, but if they get compromised, they can execute malicious JavaScript on your website. So a possible solution is to add an integrity attribute to the script tag, which is basically a hash of the content of the script that you're sourcing. So if you go, for example, to jQuery official webpage and you search for the code snippet to include, you will see a script tag that already includes the integrity attribute. But if you want to calculate it yourself, you can go to some websites like srihash.org to calculate this hash. This means basically that the browser, it loads this JavaScript for, in this case, cdnsjs.cloudflare.com, downloads it, compares the hash of the content with the one that you specified there, and only executes it in the context of your web page if the hash matches. So this provides integrity guarantee. SRI is supported by all modern browsers, in particular Firefox, Chrome, Safari, and New Edge. It's not supported in IE. Yeah, that's the only one. New Edge is support, so that's pretty well supported. The second one is same-site cookies. So same-site cookies is an extra flag in the cookie to basically mitigate cross-site request forgery attacks. So here we're no longer talking about XSS, we're talking about cross-site request forgery. The idea with cross-site request forgery is that you turn the browser against the user. So for example, you have a page on evil.com and you, I don't know, embed a form or something that does bankingwebsite.com/withdraw and then an action that has some kind of side effect. So the problem is that this action is authenticated. So it's sent, the victim sends its own cookies to the vulnerable server. In a lot of cases, you don't want that. Like, you want your cookies to be sent only if the request originates from your origin, and not if it is cross-origin in a way. If it originates from a form or an image or anything from another origin, it can be attacker controlled. So the idea is you can assert that a particular cookie should only be sent with the request initiated from the same site. So basically, this is a flag like, you know, path or domain or expires, you know. It's called same site, and it can have two values, strict and lax. Strict means always. Basically, cookies are not sent when there is cross-site navigation. This can be problematic in case of, for example, GET requests, because this applies also to GET requests. And it means that, for example, if you want to send a URL via email, and you know, from gmail.com, your friend will click on that, and it will not be logged in, because there will be cookies will not be sent. So this might be a little bit too much sometimes. So the idea is to also add a lax value. That means cookies are not sent when there is cross-site navigation, and an unsafe HTTP method, with more than unsafe, I would say, HTTP method that implies some kind of side effects, like post, put, or delete, which are usually by RFC, the HTTP method that you should use if you have a state-changing action or an action that has side effects. So for example, in this case, GET request would have a cross-site navigation cookie sent, while these unsafe HTTP methods would not. So for example, a post with a form, which is probably what is used for a withdraw action on a vulnerable website, would not send cookies. So this is pretty cool. Same-site cookie support in browsers is unfortunately a little bit more limited, but it is supported by the major browsers, which are Chrome and Firefox. Chrome supports it since few major versions. Firefox just supports it from 59, which is pretty recent. Hello. What do you mean exactly by fetch by some origin?
I mean that when there is an XSS and you want to make a cross-site forgery to another origin, the browser can detect it, even without these attributes.
But this is not about XSS, right? This is about cross-site request forgery. So you have a form that posts.
Yeah.
Will it send the cookies? Yes.
Yep.
So that's a problem. With this, you don't.
Okay.
It's as simple as that. So you don't need JavaScript, right? Even if you disable JavaScript, you have a form post. Well, you might have JavaScript for sending automatically, but let's say that you have a hidden button or something, right? Okay, so this works even in this case. Okay. So basically, it's supported by Firefox and Chrome. Edge does not support it. Next ones are site isolation, CORB, CORB, and from origin. So these are very new and cutting-edge mitigation techniques, and they're actually, well, actually, some of them are header delivered, so you as a webmaster can use them, and some are browser settings. So I'll go through them separately. Site isolation is basically a Chromium browser setting. Other browsers vendors are pushing in different directions to achieve the same goal. But we can talk about that more in detail if we have time. Basically, if you go to Chrome flags, you can enable strict site isolation, which is will be on by default in the next versions, but so far it's opt-in. This means that the browser puts pages from different websites in different processes, and also put some safeguards preventing some kind of inter-process communications between them. So why doing that? This is an extra security boundary, and here we're talking about not web vulnerabilities, we're talking about binary vulnerability, memory corruption vulnerability. In particular, in this case, we so strict site isolation has been around for more than 1 year, if I remember correctly, and now it's very important to actually enable it because of Spectre and Meltdown. So these speculative execution bugs that you might have heard of, basically it's very important to also avoid loading, let's say, document content, so HTML content, in static resources such as images. Because basically what you could do is read memory from the process. So the idea is, let's try to avoid that sensitive data might end up in the process in the first place. And this is exactly what CORB, or cross-site resource blocking, is, or now it's called read blocking. In the it changed name, but R is still there. It used to be called resource blocking, now it's called read blocking. This is an important part of site isolation, restricting which cross-origin data is sent to a renderer process. For example, we want to avoid that loading cross-origin HTML in image tags, just to basically taint the process with having potentially sensitive data. So you might think, I don't care if I do image source sensitive PII.html because I can't read it. Here we're not talking about web, right? We're talking about dumping the memory of the process. So you can read it in that way. So no same origin policy. We're not talking about web. We're talking about processes here. And it's pretty cool that the web platform is trying to also cover these cases. And this is actually pretty new. It might also be surprising. From origin is a header-based mechanism. And you as a webmaster can say, I want to prevent my resources from being loaded by non-whitelisted origins. This applies to images, this applies to HTML, and whatever. So this was originally thought as inline linking protection, or hot linking protection. I don't want my images, I don't know, I am imgur.com. I don't want my images to be loaded from random forums that leech my bandwidth. Or, you know, I don't want to be /dotted. I don't want to be, I don't want to pay for bandwidth by having, random people source and embed heavy resources. But it is becoming more and more important because of Spectre and Meltdown. From origin, CORB, and site isolation are together basically form a strong mitigation against this kind of speculative execution attacks, and they are a little bit orthogonal from one each other. Most of them are if I remember correctly, this is still being discussed, but from origin has not been implemented yet, but CORB will probably be present in Chromium only, and Firefox will have a similar thing, but stay tuned, this is being discussed. Now up to upcoming mitigations that that are not there yet, but we'd like to see getting traction. Suborigins are a very promising mitigation that basically, so what is a web origin? A web origin is a tuple that is basically the security boundary of the web. This tuple has scheme, which is HTTP, HTTPS, file, host, and port, right? This is the definition of origin. Suborigin proposal says we should add another part of the tuple, which is an arbitrary namespace that is provided by a header by the server. So you can have a suborigin header, server-side, that does, I don't know, it says test, or account area or admin area. This physically separates this origin and makes it separate. This means that an XSS in those pages will not be able to access data from the main origin of the host of the domain or others. So this allows very coarse-grained separation in cases it's hard to have separate domains or separate subdomains. So the safest is, of course, having a lot of subdomains. Like, for example, googleusercontent.com. There is a reason why we did Google user content, because it allows to upload user data. We want to separate from google.com. Subdomains are somehow okay. They're not as okay for cookies for some reasons, because cookies are a little bit weird. But the idea is, think of WordPress. WordPress maps on /wp admin, an admin area, which might be XSS prone because you install plugins and so on. It would be cool to isolate it as if it was from your site adminarea.com, right? So make it work, but in case there is like some kind of XSS, it's isolated from the rest of your site. And the same for sensitive functionalities such as a password reset. So without going too much in technical details, the thing is an origin will have a sub-origin. And the idea is you will need some refactoring to make sub-origin to parent origin and sub-origin to external origin communication work. In particular, sub-origin to sub-origin works by default as long as the server provides the same sub-origin header. So there's a page and has sub-origin admin area, and then wants to communicate via, I don't know, XHR or fetch or post message to another page that is on the same sub-origin. So with also sub-origin admin area, that works, no problem. Like if it is same origin, because it is same sub-origin. Sub-origin to parent origin, this is blocked by default because that's what we want, right? We want to separate. But to communicate sub-origin to origin, you need to add a new header, which is like the coarse header, access control allow origin, so that, but in this case, it's called access control allow sub-origin with the name of the sub-origin. As simple as that. And sub-origin to exter is like cross-origin with coarse, so access control allow origin. So I wanted to give you a quick demo, if it works. So an intern of our team, Elena Ionescu, created a Chrome extension that unfortunately is not public because it uses some, let's say, very experimental parts of Chrome API. So we need to fine-tune it a little bit, but if sub-origins get traction, we'll definitely open source it, publish it on the Chrome Web Store. This helps prototype sub-origins. So for example, let's say that we have, for example, for historical reasons or for marketing reasons, we have some static web page on a very sensitive domain, which is www.google.com. So www.google.com has PIIs, has very sensitive data we don't want to. So an XSS on www is very bad. But unfortunately, these pages, these are static pages on /about, they might have some vulnerabilities. They might also come with be written by external people, so we might not be as confident about the code quality. So what we want to do is we open sub-originator, hope you can see it, yeah. And we put a target site, which is www.about, and then we start it. So you see, it's debugging the window. Okay, so in this case, we just, navigate this a little bit. We open a few, this is external, a few links. Then we stop it here. Oops. Ah, shit. I didn't have to do stop, sorry. We do display report. Ooh. Yes. Yes. Just a sec. Okay, I probably need to, yeah. Okay, so let's open a few stories that should load, MP3, do XHR, there is a video here. Oh no, that's audio. Okay, should work, right? Let's do display. Yes, this is a display report, and we see that it's basically only sub-origin to sub-origin communication. So this is fine. This means that works out of the box. So as long as we put the sub-origin header, this will work. So this is fine. No refactoring is needed. But if we go, for example, to a more complex application, which is a Google Finance, that is like on google.com/finance, also for a historical reason. And we just go around a little bit. We have to be careful not to exit the origin. Okay, then we display report. Yeah, you see that there is some communication between the sub-origin to the parent origin and from the sub-origin to external. This means that sub-origin to external probably works already because otherwise it would be blocked already from, let's say, www to an external. So this means that the course is already in, but what we need to focus on is sub-origin to origin. This means we have to add this access control allow sub-origin header. So, for example, in this case, we are talking with /search, /async, and these requests will have to have an extra header added. So, in conclusion, this extension really helps in prototyping and seeing how much refactoring is needed to use this and have all the benefits of sub-origins. Sorry, it's really hot. Origin policy. Origin policy is a proposal, hasn't been implemented yet, and the idea is to make some of these mitigations by default, like HSTS for TLS or HTTPS. So the idea is you can add as many policies as you want, like content security policy or referrer policies or other policies, to an entire origin by default, like pinning. So it's sent one via manifest, and then every resource gets those policies applied. This is very cool because it complements header-based delivery and increases coverage. For example, let's say you have a reverse proxy and you have different servers. I don't know, you miss deployment on one, or you have some parts of the stack that do not trigger your code path where you added these headers. I don't know, an error page, a debug handler, things like that. Like these things happen. Then you will find out that maybe you don't have this protection. In this way, you're guaranteed to have this protection applied to the whole origin. Or maybe even parts of it in the manifest, you can be a little bit more fine-grained. But as I said, this is a proposal. So if you search for origin policy on the W3, you will see that are actively discussed. It's been actively discussed. Another one is feature policy. It allows the web developer to selectively enable and disable different browser features and APIs, such as going full screen or using geolocation or using web USB. In combination with origin policy, it's very good for restricting, for example, geolocation to, I don't know, search on map action. You need geolocation only on one action, and so you say explicitly, I will need it only on this action. So an XSS on any other page will have a harder time, for example, getting the user location, because it will be disabled, hard disabled on other pages. I mean, this is not a security boundary. I mean, you could do things. You could try to do lateral. I mean, you could try to jump from one to the other, but this hardens and makes it harder, raises the bar. I think, well, we are on time, or slightly earlier. So if you have any questions about CSP or the new stuff, please ask us. Thank you.